Hello friends, in today's video I'm going to be talking about better cooling solutions for this LC575 motherboard. But please know that even if you don't have an LC575, what you're seeing here can really apply to any 68040 processor where you're overclocking it. More specifically, I am using this LC575 motherboard inside a Color Classic, and that is known as the Mystic. I have K-Koba's Spicio clock here. I've done a complete video on that. I'm not going to go into details other than just to say that I have been able to, thanks to this 60 nanosecond VRAM, overclock this full FPU CPU to 50 megahertz stable. Now that was before I installed this 2E card. This is an Apple 2E card. And prior to installing it, I was able to get to 50 megahertz. After installing it, I had to downclock to 49 megahertz before the max side was stable. And I don't know if that's because it has inadequate cooling now, or if it's because the power supply is unstable somehow. I'm not able to really ascertain that very well. So what I'm going to do is apply better cooling. Now, this is an aluminum heatsink. It's gold anodized, but it is made of aluminum. It is affixed to the top of the CPU using this run-of-the-mill standard thermal tape that anyone can buy on Amazon, and it holds it on there extremely well, but the thermal conductivity of this tape is not so great, and I'm not able to determine the exact temperature of the CPU because only modern computers are able to do that and not in vintage Macs. And even though I did put a sensor on the top of the heatsink, that only determines the temperature of the heatsink and not the temperature of the actual CPU. The best way would be for me to put a temperature sensor underneath the heatsink, right smack in the middle, but I cannot also put the heatsink on it as well, you see. So it's not possible for me to determine the exact temperature of the CPU. All I can say is that the temperature of this heatsink never exceeded 60 degrees Celsius, even before I put the fan on. And after about an hour of running, if I touch it with my fingers, it is, well, fairly warm to the touch. It doesn't burn my hand or anything. But again, if there's not a lot of heat transfer through the thermal tape, it could be that the CPU is getting very hot, but it's just not able to be adequately cooled, which is why I am going with a better cooling solution. Now, this cooling solution you're looking at over here is a 60 millimeter heatsink. This chip is only 45 millimeters. The heatsink I have on here now is 45 millimeters, so this is going to be larger. It's also taller than this heatsink. This heatsink is 10 millimeters, and this is 20, so it's twice as tall. It's much wider, and this is pure copper, and this is aluminum. So copper will transfer heat better. It's significantly bigger too. And this idea originated not with me, but with YMK Devices, maker of Mac SD, over at the Tinker Different forum. I borrowed this idea from him after asking him some questions, so I'm basically copying his plan and giving you all the details. And so what I'm showing you here is all of the tools that will be involved, including a C-clamp, because what I'm going to do is remove the heatsink that is on this CPU, and then I'm going to clean it off with alcohol and make sure it's just as clean as the stock LC version CPU. And then I'm going to, just for a test to show you, I bought this transparent acrylic, and what I'm going to do is apply some of my thermal paste in the middle to show how well it spreads. And I want to see that first because the only way I know to affix this particular heatsink on there is with thermal glue. And I'm not going to use all thermal glue because thermal glue has, well, almost the same bad properties as this. It doesn't really transfer heat as well as regular thermal paste like MX4. So I'm going to use MX4 as a pea-sized drop in the middle and use thermal glue at the corners to hold it on. And then I need the C-clamp to hold it down for 24 hours for the thermal glue to cure. Now you might say, well, why are you using MX4? Isn't something like, well, this thermal grizzly cryonaut better? And the answer is yes. For the first year or so, I've done a lot of studying on thermal grizzly cryonaut, and for some people they say it lasts 1 year, other people say 2 or 3 years. It really depends on the temperature of the CPU and so on. But the reason I ultimately went with MX4 over what I've used in the past, thermal grizzly cryonaut, is because this will last 8 years according to the manufacturer. And I'm not going to, rip this off every year because it's going to be glued down. So having a long life thermal paste is paramount. And yes, I am aware that MX5 is out. However, I've read a lot of reviews on it, and it's really not that much better than MX4, and it's harder to spread than MX4. So because of that, making this easier to spread I thought would be an advantage. Also, this is much cheaper than MX5, and there are a lot more reviews on this. It's just an all-around good buy, especially because of the 8-year life. So let's go ahead and proceed with the plan. Now, the reason why I chose a 60mm heatsink, this is just for demonstration purposes here, is because even when I put it right smack in the middle, it will barely fit, right? So here's the VRAM, and it does not touch. I've got a little gizmo here to pop out the VRAM, and it still has a little bit of space over here on the side, so it doesn't touch the card. This is a 2E card, and it fits just right. Now the airflow, you know, the vents, I want them to go out this way because I'm going to have to figure out an airflow solution, but this direction would be going out the back. So if I were to blow fan wind this way, then that would be better than having it facing like this. And so my intention is to put it on the CPU such that it looks like this when it's finally glued down. So this is going to be my first test. I'm going to try to get, they say, a pea-sized drop. A pea is pretty big, but we'll see if that does the job. And then I need to apply my glue to the 4 corners. And in theory this should work, because when you put it in the middle this will make a circle and it should somewhat exclude the 4 corners. Although if I don't get it exactly in the center then it would be a problem, but we're going to find that out now. Alright. And this was the result with the C-clamp. I didn't quite put enough on in the middle, so I'm going to have to clean it off and give it another go. Okay, let's try that again with more paste this time. And this time we see we've got full coverage. It does overshoot the glue at the edges a little bit, but you can still see on all 4 corners there is the glue. So whether or not that's enough to hold it on there, I'm gonna find out. But anyway, the point is we wanted to make sure that our good thermal paste reaches the outer middle edges of all 4 sides, which it currently does. Well, I thought it was going to be much harder to get the aluminum heatsink off of my full FPU 040, but no, it wasn't, and unfortunately we can see the reason why. There's only residual tape residue here, and it may be hard to see on the video, but actually the only area that made contact seems to be this area here, this area here, this area all along the top here, and I cannot see any signs that the tape made contact anywhere in the middle at all. So, well, the fact that the tape, either this heatsink wasn't very flat or the chip isn't very flat, either way, it's just, it wasn't making contact, and except for the outer edges. So the cooling was clearly inadequate, that this tape and this heatsink combination just isn't working. So hopefully by putting the 100% pure copper heatsink with a malleable compound on there, it's going to fill in any of the gaps if it's not perfectly flat, either the top of the chip or the heatsink itself. Now if we look at the bottom of the pure copper heatsink at one corner here, we can see it's very finely machined. It's almost like a fingerprint level of fineness, these lines, and you really can't feel them with the fleshy part of your finger, but if you run your fingernail over it, you can feel it a little bit. Even so, I decided not to lap this or sand it down because I've watched a number of YouTube videos on it that shows it really doesn't make a big difference, so I'm just going to leave it like this when I put it on. The primary text is up here, and this is the way it's going to go on the motherboard with the connector side facing this way. And as I said before, I want my vents to be such that if I have airflow, I want it to go out the back like this. So I want to make sure that I put it on that exact way once all of the glue and the paste is on. Now I wiped this down good, cleaned it off with 100% alcohol, and you need to make sure there's no dust on it. So I'm using my rocket blower keep that off. I also wiped down the bottom side of the copper heatsink with alcohol as well. And I'm going to try to remember the mount that I need to put on. So again, the text is up here. The connectors are going to be this way. And I'm going to put the heatsink on such that this little gap part, that gap part is going to be on this side, which is the VRAM side. Okay, and so this is the tricky part because I need to get it on right in the middle. But the gap is over here, the text is over here. And so here it is. I put a little thin piece of wood underneath it because it's a little bit bigger than this circle and I wanted more surface area to touch. I don't know if it's going to dent in this gold square or not, so anyway, the surface area is a little bit bigger. And it's impossible for me to quantify how much pressure I had to apply, but I applied enough pressure until the paste started coming out the middle of, the gray paste, the MX4, started to come out. The glue comes out first, of course, but I kept pressing, not with all my might, not even close to that, but it's down there pretty good. And then the paste started coming out all four sides. And well, I think that's about the right amount of pressure. Now, if we look at it from the side, we can see that I put two thin pieces of wood. They have a white piece of paper on top to make it perfectly flat. And I needed to do that because I didn't want any of these fins to bend. So I wanted to make sure that I had a 60mm wide piece of wood up there, because the little red piece is all I have, and that's too small. That probably would have bent the fins. And that's why I applied the wood up there. And it seems to be working fairly well. You can see the fins aren't perfectly straight, but they weren't perfectly straight when I first bought it, so it's okay. And here it is, 24 hours later. I have no idea if this glue is supposed to dry hard or soft, but if I push on it with a toothpick, it seems to be soft. Is that because it's not fully dry? It doesn't seem to break. Maybe it just dries in a rubbery state? I'm going to have to investigate this, and it's probably best for me to just leave it as it is for another 24 hours, giving a total wait time of 48 hours. Well, it's been 48 hours, and if I press on it, it's still soft. Not too surprising since this is a silicone-based glue, so I'm going to go ahead and unscrew the C-clamp. So if we take a close look, this is the upper left corner, and that's the only place where there is no pin. You see pin here, pin here, pin here, and we see that there's no pin here. So that tells us exactly how we need to orient it. Specifically, this little part that juts out is going to be going towards the VRAM. So here we go. And that seems to be secured in there. Now, before pressing down, I want to put this little piece of foam under where the CPU is so it doesn't flex the board when I press. And since this copper heatsink is pretty heavy, it shouldn't take much effort to press him down. And with the board sitting on its side, we see the heatsink is holding on there. So the glue is working. Now with the motherboard installed, I have to think about fanning it because I've got my 40mm precariously hanging over here on the side. I bought this 60mm by 10mm fan that theoretically could fit on top of that heatsink, but it actually won't, because if you look deep down inside, there's a floppy ribbon cable back there that would touch against it, so I can't put a fan on top. I also can't put this 40mm fan on the side either, firing out the back, because as you can see, it just is too tall to do that. While not ideal, just for now, I decided to put my Noctua 40mm fan on the edge of the Apple IIe card because there was a hole that I could bolt it there. It's just on top of Spicio clock, but not touching. This is the PRAM battery, and of course this is the CPU heatsink. So I'm still thinking what's best to do, but for now this fan will provide more airflow than no fan at all. And with the motherboard installed in the Color Classic, you can see the 40mm Noctua fan is here. It only rises up just a little bit over the heatsink, and here's the floppy cable, plenty of clearance. Here's the SCSI cable, and there's clearance, so plenty of space here so the air can flow down through the fan. Okay, so here's my first test. I've got my Spicy O'Clock overclocker set to 50 megahertz. And this is, well, it was fairly stable before I installed the 2E card, but after that, unfortunately, it has some stray pixels. Now anyway, I've been testing it for a little while here off camera with Norton System Info and also MacBench 3.0. I've got a spinning platter hard drive in there, so it generates a lot of heat, and it also draws quite a bit of power. And then I proceeded to some games. You can see over here on the side I've got various games, including Wolfenstein 3D, which I finished the first entire level playing it. And then I went to Marathon and been playing that for a while. I'm just going to launch Marathon again just to show you. But Marathon has a demo mode that really taxes the CPU about as much as playing the actual game itself. So I'm going to let that go into demo mode while I put my hand behind the back. I have the back panel completely removed. I don't have my temperature sensor hooked up yet because this is just a first time quick test with the new heatsink. But when I put my fingers through and make physical contact with the 60mm copper heatsink, it's just not hot to the touch. I mean, it's warm, of course, it's warm, but it's not blazing hot like the old aluminum heatsink was. I mean, I could barely put my fingers on it. It got close to 60 degrees Celsius, but even though I've been, like I said, been going through all the benchmarks and playing Wolfenstein 3D and also playing Marathon, again, I'm touching it here, and it's just not, it's not that hot. Now, of course, you got to keep in mind that this heatsink is physically much larger. It's copper too, so I'm assuming also with that paste that it's going through the motions of dissipating the heat a little bit better. Let's just go ahead and quit out of here. The real test though is in the Finder, because if we look close at the Finder title bars, we can see some stray pixels here. And when I move the window around or just move the black arrow pointer across the title bar area, you can see that there's these little pixels coming out, and that's unfortunate. In the past, I thought that was due to the slowness of the VRAM, and who knows, maybe it still is, but I was hoping that replacing the CPU with better cooling would eliminate that, but so far it hasn't, and that could be just because the thermal paste needs some break-in time. So I'm going to continue testing it and see if this goes away in my second test. Now I'm going to do things a little bit better this go around with my Fluke 116 meter. I'm going to set it to the temperature setting here, and I've got my temperature wire connected, and I was thinking, well, how in the world am I going to do this? Now obviously for the best reading I would need to have my temperature wire to be placed underneath the heatsink and above the CPU, but I can't do that. And there is a way to do it underneath the socket on the bottom, but that's a little bit more fiddly. And actually, by the way, since YMK of MacSD inspired me to do this, I should just mention that MacSD has the ability to hook up to 8 temperature sensors to the product so that you can actually do under the socket testing. And I'm not going to do that in this video, but it's pretty neat. The developer of MacSD recently posted his experience on how he did that. So if you have a MacSD, you could use that instead of a Fluke meter to do some very accurate temperature testing. And also it's to set up a variable speed fan. Now, I don't need a variable speed fan in this. In fact, speaking of the fan, I think I'm actually going to leave it here. It's got a piece of rubber there. It doesn't really vibrate that much. And what I decided to do, if I take off the card, is I used my spacer kit, and I added a little bit longer black piece, and then I put some soft Velcro down here on the board so that this will just barely touch the Velcro, and it's not going to, if there is any vibration, it's not going to touch the traces on the top of the board. So the purpose of the fan is to, originally I was thinking it would be nice to have it blow directly onto the heatsink, but as I continue to test, the actual, even though it's firing straight down and pushing air straight down, it's moving the air all around. And it is better than no fan at all. And I thought of different ways to put a fan on here, but really this is kind of ideal, the way that this is set up. So how am I going to connect my temperature sensor? Rather than going under the socket, what I'm going to do, at least for my first round of testing, is I'm going to keep the back panel off, and then I'm just going to put it here in the middle. And then for my second round of testing, I'm going to take the back panel and put it on, which would have to be this way. This is a flippy floppy 3D printed back panel from K-Koba, and I can put it through this hole here because I don't have the flippy floppy installed yet. And then for my third round of testing, I can put it through the back panel and see if having the back panel on makes any difference or not. But basically, to install the wire, I have this has a little metal tip here, and I have it bent just very slightly. So if I put it somewhat towards the middle here, and then I have a piece of plastic, it's actually to help me white balance my camera, I can push it down all the way. And it's in there fairly secure. And it's making contact. You could hear it drag on the copper heatsink. So it's coming in physical contact. And now you can see 20.6 degrees. This is the temperature of this heatsink right now, which is roughly the temperature, ambient temperature of this room, actually. And then I know what the temperature is when it's shut down, and then we can do the testing now to see how it's going to be when I run benchmarks and games. And here is my test setup. This is actually my third test, the first test being my finger touch. The second round of testing was with the back panel off, and this third round of testing is exactly like the second round, except the back panel is on. And I have my temperature sensor attached to the heatsink. It's currently at 19.2 degrees. This has been left off for 24 hours. It has not been turned on. So this is the true temperature of the heatsink without any power. And then this is the ambient room temperature meter here. So we're getting just a little bit over 22 degrees Celsius for the room temperature. I also decided to hook up my Mach 3 joystick and my floppy EMU because this is a typical use case, because I have the 2E card installed, and so to use that I need to have a joystick and the floppy EMU. When adding these two items, it will draw more current, generate more heat inside, so it makes sense that I should add this. By the way, the hard drive is a true hard drive. It's a spinning platter drive, so it's going to draw a fair amount of current and generate heat accordingly. So we need to keep all of that in consideration when doing this testing. So what I'm going to do right now is flip on the power in the back, and then I'm going to turn on the power here, and we're going to boot up. And the first test is going to be the idle test. So I'm going to let it boot to the desktop and then start a 30-minute timer and just leave it there, and then show you how the temperature goes up. It's already starting to go up right now. You can see that it's currently 20 degrees. So slowly going up, and we'll see how the temperatures go. And just to let you know, I haven't changed the clock speed. The clock speed is still set to 50 megahertz. 50 megahertz. So I'll just leave it right here for 30 minutes. Okay, it has been 30 minutes and the temperature has risen to 40 degrees Celsius. The ambient room temperature really hasn't changed much at all. So, and by the way, when I had my old aluminum heatsink on, it would hit probably about 55 degrees Celsius right about now, just at idle. So we see a reduction, a very noticeable reduction in temperature. And now what I'm going to do is I'm going to, with my floppy EMU connected, load up the 2E startup here. We've got it in color, normal speed, and I'm just going to play some Total Replay games for a while. By the way, if you don't already know, Total Replay 2 is out, at least the alpha version, and Total Replay version 5 beta 3 is also out. So for those of you who saw my previous video, you can update your Total Replay, but this is called Instant Replay. And Instant Replay allows you to play all of the games that they removed from the regular Total Replay because they wouldn't fit. So these are mostly sports-based games that they have on here. And they've also got Autobahn. So what I'm going to do is just play some of these games for 30 minutes and see what the temperature is then. Okay, well, I've been playing for 30 minutes now, and this is Winter Games, by the way, the biathlon. I have long loved winter games. 41.6 degrees Celsius is the temperature that it has risen to. Ambient temperature is the same at 22 degrees. So I'm going to get out of here and quit. Yes, we want to quit. And then I'm going to test for any artifacts. Now, this is an important test. I usually put the black arrow pointer up in the title bar, and if I can detect any pixels appearing, then that's bad. Because if it gets really bad, the pixelization, then eventually the computer will freeze. But if I look closely, I am not. There's some minor pixelization. It's almost impossible to see. It's very subtle, but just a tad bit of a little bit of stray darkening, but nothing significant. Okay, so what I'm going to do now is run a benchmark, Norton, system info, and we see here it's going to take advantage of the FPU built in, 50 megahertz. I'm going to go ahead and run this now. Okay, and we're finished up here, and this took almost 8 minutes to complete, and it's the score is roughly in line with my other past scores. So it didn't really rise too significantly, but it did go up to 42.1. And so now what I'm going to do is go back to the Finder and do my little pixelization check. And I am seeing some pixelization in the title bar. It's not what I would consider severe, but I do notice some discoloration. Now what I'm going to do is run MacBench 3. I find that it does quit about an hour in. At least it did during my second round of testing. So I'm not going to I don't really know what's going to happen this time, but all tests is what I chose last time. I'm going to start that now. It says it's going to take a while. And then I'm going to just say OK. Start my stopwatch. And then I'm going to let it run for about an hour. And right on the button, unfortunately, it unexpectedly quit just about 1 hour into the testing. The fact that it is repeatedly quitting after the same amount of time shows that it's probably not temperature related, and as you can see, 42.4 it's just not a very hot temperature anyway. So maybe it just one of the tests doesn't like this high clock frequency. Not sure. But the final test that I will do is running the marathon demo for about 25 minutes. And then we'll see what the final temperature is. Okay, it's been 25 minutes here. So we can see that the temperature really hasn't risen much at all. And what we can do is check our little pixelation by moving the arrow pointer, and I'm seeing some pixelation. Marathon usually does it. I mean, I wouldn't call this very intense, but there are some stray pixels there. So basically, this is telling me that, well, the new heatsink is clearly superior to the old. The old heatsink was going all the way up to 58, almost 60 degrees Celsius, and this hasn't even broken 43. This is telling us something that's good, although the pixelation is telling me that there's, I guess it's just the slowness of the VRAM. That's really the only thing I can see, because this is a graphics anomaly, and the only thing that's really driving that directly would be the VRAM. But anyway, let's look at the round 2 and round 3 numbers here. All said, I'm quite pleased with this 60mm copper heatsink solution and wish to humbly thank YMK Devices for the detailed guidance. Also, a huge thank you to Angellis, Mauro Acciaccaferri, Philippe ASTIER, and Gavin Maxwell for generously supporting this channel by PayPal. Be sure to check the text description below for links to everything you saw in this video. Now it's your turn to go out and cool those piping hot 68040 CPUs with a better heatsink. Thanks for watching today, folks, and have a great week.